Hey everyone, Mr. Fritz here, and in this video we're going to talk about adding and subtracting, and a little bit of graphing. So let's just jump right into it. First, let's talk about adding rational expressions. Think about how you add things like 1/2 plus 1/3. You can't add them as they stand right now. You need to change the fractions to have common denominators. And so in this case, you'd multiply this by 3/3. You'd multiply this by 2/2. And so you'd get 3/6 plus 2/6. You add those up, and then you have 5/6. Let's think about what we were doing. We were trying to get a common denominator, and the way that we do that is we multiplied each fraction by some form of 1. This is a legal move because I can multiply 1/2 by 1, and it still stays 1/2. So we're going to apply the same mentality or the same strategy to these rational functions. I'm looking at my factors or my denominators, the factors of the denominators in these two fractions. I've got an x plus 2 and I have an x. If I think about what the least common denominator is between those two, it's really just going to be the product of these two numbers, or of these two factors. So I'm going to multiply this first fraction by a form of 1, x over x. I'm going to multiply this second fraction by x plus 2 over x plus 2. And I'm multiplying by the quantity, so that's why I'm using parentheses here. So when I look at my denominator, I will have, for this first fraction, I'll have x times the quantity, x plus 2. And my second fraction will have, x times the quantity, x plus 2. And then I just multiply also on top as well. So this is x squared, and then this is, I'm going to distribute that 4 through to make that a 4x plus 8. When I add those two things together, I just add across the top, just like I do with my regular fraction problems. So this is going to be x squared plus 4x plus 8. All over x times x plus 2. Now you notice I did not multiply through on the bottom, and that's because I always want to look to see, can I factor further? If you can simplify a fraction, you want to. So let's take a look at this polynomial, x squared plus 4x plus 8. I don't think that factors. I see factors of 8 would be 4 and 2, 8 and 1. It doesn't look like I'm going to get to a positive 4, so I think this is done. So I can't simplify this any further. This is my final solution. The one thing I should add then are my restrictions. And my restrictions are that x cannot equal 0, since that would set my denominator equal to 0, and it can't equal -2 either. So this is my final solution. Let's take a look at another example where we're adding two fractions, and the same process. I'm going to multiply to get a common denominator. So I'll multiply this by x minus 1 over x minus 1, and I'll multiply this over here by x plus 2 over x plus 2. So my denominator will be x plus 2 times x minus 1, and then plus, and this will be x plus 2 times x minus 1. Over here, let's multiply the 5 and the x plus 2 together to give me 5x plus 10. And over here, let's multiply those two together to get x squared minus x. I combine everything together, and I'll have x squared plus 4x plus 10, and that's all over x plus 2 times x minus 1. Let's see, can I factor this? I don't think so. I'm done. So let's state the restrictions. X cannot equal -2 and +1. So as long as you remember, this is just like adding fractions. I mean, that's what you're doing. If you can remember how to add fractions when they're not with x's, it's the same process of adding fractions when you do have x's in denominators. So here's a you-try example. Why don't you pause the video, give this one a shot, and we'll see how you did. All right, here's my work for that one. Once again, you take a look at the numerator, see if you can factor it. You cannot factor it any further, so here's my final solution. Here's another you-try. Give this one a shot, pause the video, and see how you did. And here's my answer for adding these two rational expressions together. Up next, we'll do subtraction.